Hello and welcome to another one of my videos. In this one we're going to be looking at the second part of this wooden bicycle type chain that I did. I promised that I would do a sprocket for it. So it's going to go in there. I made this one, now I'll make another one for the other end. Now I've already got a blank here. It's a pulley that I had made for something else that I'm going to recycle. Now I need to make a decision. Do I want a specific number of teeth to be able to do ratios and things like that, or does it really not matter? Because that will dictate the size and shape of things. First I'm going to need to know what the distance between the pins are, and they are 15 millimeters. So I'm wanting 15 millimeters between centers on my teeth. So if it's not important how many teeth I'm going to need, I can just take my disc and mark off on a piece of paper, stiff paper or card, 15 millimeter increments. So I'm going to take my disc and the tape measure that we've just made, wrap it right around the outside of the disc and see how the numbers line up. And we can see that they don't line up. There is a gap there. Now I need to reduce the diameter of the disc until those numbers line up precisely. So there we have it, right on the 27 teeth. So I'm going to take a pencil and transfer those marks to the other side to have a reference as to where I'm going to have the points of my teeth. Now we could have worked that out mathematically. For example, if we had 15 millimeters between each tooth and we want to 27 teeth that we know that we're going to get, that will give us 405 millimeter circumference. Then we're going to divide that by pi, which is 3.14, is close enough for us, and that will give us 129 millimeters in diameter. Divide that by 2 will equal approximately 64.5 millimeters in radius. And let's measure that, and sure enough, yes, it is close enough to 64.5 millimeters in radius. Now if I want to actually do one with specific tooth numbers, like this one I want 16 teeth, well, we could do the calculation in a similar sort of way. For example, I want 16 teeth and I'm going to times that by 15 millimeters, which is going to give me 240 millimeter circumference. Then divide that by pi, which is 3.14, and that's going to give me roughly 76.43 millimeters in diameter. Divide that by 2 will equal 38.2 millimeters roughly radius. So I know how wide or how big my disc is going to be. Then I can start to look at dividing the teeth. So if I was to draw a circle of that 38 point whatever, 0.2 I believe, and if all goes well, you should be able to mark off every 1.5 centimeters or 15 millimeters, and they should join up. And the last one is a little bit up, but it's close enough for me. Yes, there's my 16 divisions. Or we could actually get a lot more precise and use angles of a protractor. So on a sheet of newspaper or a piece of paper like this one, I'm going to draw an arc with a compass on the paper like that. To find 45 degrees, we go from one point here, scribe a mark. From the other 45, scribe another mark. You're going to go from that point to the corner point, and that's going to give you 45 degrees. To get your 30-degree angles, you take the radius from here, and from each corner you're going to go, there's one mark, and one from the other corner, the other mark, but it's not actually accurate to a tenth, because of pi it's 3.1, so there's a little bit bigger there. On bigger circles it's noticeable. So get another compass and just double check that distance. It should go 3 times through. And in this case, we're actually out by just that little half, a little fraction. But anyway, there's the 30, there, there, and there. There's 30 degrees. Now, by trial and error, you're going to set your compass and divide that one into 3 portions to give you your 10-degree mark. And that's supposed to come there level, which it hasn't precisely. Okay, you're going to do it a lot more accurate than I'm doing now, of course, but this is just very rough. Take your time over it. And then this piece between here, which is going to be 10, 20, 30, 40, 45, 50, and there's 50, 60, 70, 80, and 90. Between here and here is going to be 5 degrees, between 45 there. They should be the same, even though mine's rather inaccurate, but take your time when you do it. So that's going to give you your 5-degree marks between the 5, 10, and those ones there, the one there, there, and 50 degrees was out. And then you have your 5-degree marks. Now to get you these 5, you can get a smaller ones and divide those into 5 just by trial and error. Or you can subdivide that line or any line by any number by taking this point out here, selecting a point, make an angle of any arbitrary distance you like, and also with a compass an arbitrary distance that you like, and say divide it into 5, 2, 3, 4, 5. There's that point there. Then we're also going to draw the line that is roughly parallel with that, the one we're going to divide into 5, so that we take that line out there to here. We're going to divide this line into 5 by those 5. So now we draw a line from that last point through the last point there, and with our compass measure the distance between the end point here with that one, go the opposite direction, then take, so that we have a line going through here, through that point, out extended, then the same distance as the one we've arbitrarily divided. Also make a curve, and then the same distance here from that one there, and come from the other end of the line made it not quite acute enough. It'll be out here, so that you're going to now get a line from here which will be parallel with that one, and one that will eventually join at the same distance. There it was. Then mark off those 5 arbitrary distances there along this one. Hopefully you get the idea. Then connect the first one here with that first one and subdivide that. Move to the next one, subdivide, third, and the fourth one, and then the fifth one. And that will have divided those into 5 equal pieces, which then you can transfer back down onto this one here. Four, and the fifth one. Very rough I'm being, but you get the idea. 1, 2, 3, 4, and the fifth one. So there's 1, 2, 3, 4, 5 divisions. Now, if you're neat and tidy, they should be nice and equal. 1, 2, 3, 4, 5. And you can replicate that through all of those to get your degrees. But first I'll just double check all of that with a precision set of these. And I find that I am no more than half of a degree out on my 40 degrees is half to 2/3 of a degree out. 45. Everything else is within a degree, within half a degree in fact. So now I can just transfer all those out. Now, even though I've been rather sloppy for this tutorial, I've got within a half a degree. We can actually get down to a 1/10 of a degree of accuracy by taking this stick here and sticking a piece of cardboard on it here, and then marking off the 10 degree point here, and then using this method here, subdivide this into 9 pieces. So it's divided into 9 pieces that 10 degrees, so that when we place it on here on the point, you're going to go out to as many degrees. For example, you want 60 something degrees. Now if you've been accurate, like here we're on 15 degrees, the 0 point here should be the full 10 degrees. But if I move 0.1 degree, you'll find that this number 1 lines up with the next one. 0.2 degrees, that one will line up, 3, 4, and then when you're at half a degree, the 5 and the next one lines up. So the ones that line up gives you the point, or the tenths of a degree, until you get the full to the next degree, and it should line up with the next degree. So now we can work out that 360 degrees of the circle divided by 16 teeth equals 22.5 degrees between teeth. So now I can put a piece of paper in the corner here and then transfer those. I can go my 20 degrees, 22, and then looking at here, go 22.5 degrees and make my angle here. The next will be 44, which will be 44 and 2 halves makes 45. And then find your marks around there, transfer that to your disc. Now if you're going to be making a lot of cogs, it's worthwhile making a board like this with a pole in the middle with your axle and the central point, and each of a circle going out here. I've already gone to the trouble of putting the different tooth counts and punched a little hole there so that this nail here goes into the hole. I'm going to secure my disc with a piece of tape just so it doesn't move, and then on this circle here, every second hole is going to be 16 for 16 teeth. Mark it off and just keep going around. To make sure I've got the right distances, I can take my 1.5 or 15 millimeters and go out on those lines until they coincide, and that is going to be my mark there. And I can double check that by doing the maths. It was going to be 38.2 millimeters out from the center, and there we have it, 38.2. So that is the diameter that we're going to be cutting it at. Now the teeth are going to protrude a little bit further than that point, and also a little bit less as well. And so we're going to draw a circle there. Now other cogs normally go around and the teeth stick out like that, but in the sprocket they're going to go in little circles like that. And that is so that the little pegs go into that part there. So they're going to go from the outside down to the bottom and back out again, down to the bottom and out again, like that. So I'm going to cut the diameter now, round it off a bit. Now in the dip, I'm going to go down the central line that takes me into the bottom of that U shape, down to the bottom line. With a saw you can cut out some waste material, or maybe with a triangular rasp. You can also use a round file or rasp to take out the rounded bottom. Then you can make a stick of the right dimension with a strip of rough sandpaper, wrap it around here, and make a cylindrical sanding piece, and use it to then sand out the complete U shape. And if all goes well, once you've done all that, it should work fine.